and the importance of the problems. And we've seen that how different algorithms help you to solve the problems. So algorithms for each type of problem. And we also discussed about the concept of linear regression, right? So then we also discussed about the what is a linear regression, and we also discussed about what is the interpretation of linear regression, and how to use linear regression to predict the value. How to assess the regression, assess how good is the model, how to assess the model is good. Right? So while I'm explaining this one, I also explained the concept of regression analysis, predictive modeling, and estimation process, and the scoring concept and the implementation part. Right? So these are the few things I discussed, and I also discussed the concept of business problem to statistical problem, and statistical problem to optimization problem, and solving optimization problem, with the help of optimization techniques like gradient descent. And that will give you the solution, and that solution will be converted into stat solution, and that is converted into business solution. So I think this is the common approach which I discussed yesterday. So at this point of time, if you have any questions, I'm happy to answer. Any questions? Online guys, any questions?
So we had this concept of R square. So when we got 75, if you're interpreting it, can we say that 75% of the times we're able to predict the value?
No. 75% of error you're explaining with the variables x. So that is what exactly the R square definition is, something which I was referring, that the percentage of error explained. When I say error, I mean to say that variance in the y explained by your x variables, right? So a couple of terminologies. This is also we call it as a coefficient of determination, or goodness of fit. How good is your fit? How accurate your things? Does it make sense? Any other questions? Uttam, yes, we will also cover the likelihood estimation. Not now. We will talk about little later point of time. 75% of data near the best fit line. No, that's not the exact answer for the R square. The R square is all about how much variance in y explaining by x variables. So because the variance of y is nothing but what, for example, like this. Suppose this is the variance of, like, if it is a straight line, there is no variance. So then I can directly fit the model. But if the values are varying, so how much of your line is able to contribute that variance? So instead of this one, instead of this one, I'm saying that, okay, if I come up with this line, some linear line, how much I'm able to increase the accuracy. With X variable, without X variable, what is the improvement in the net accuracy?
If somebody asks what is the accuracy of the model, that question.
Yes, you can say that. So how good is your model, or how accurate your model? If your R square is high, and that means that your error is low. Your error is low, that means your model is more accurate. Right? If you remember yesterday that concept I was trying to explain with the mathematical calculation. Okay, any other questions? Okay, cool. Now let's try to understand the next set of concepts which I was referring yesterday. So you remember we discussed yesterday the concepts around linear regression. Now let's understand how to build a model practically. So that means that steps for implementing the model, right? So whenever, again, these steps remain same for all modeling projects. It's not necessary for linear regression perspective. Only the technique will change in the later point of time, but otherwise the steps more or less remain same. Of course, there are few steps will change, but as I said that 70 to 80% of steps will be remain same irrespective of what problem you are solving. The problem related to regression, the problem related to classification, problem related to segmentation and forecasting, whatever type of problem you take it, the steps will be more or less similar. Does it make sense? Okay, so now let's understand how your broad steps will looks like. So as I mentioned that there are broadly three steps you have it. One is pre-modeling, one is a modeling, one is a post-modeling, right? So as a data scientist, probably you may not involve in all the stages every time. So sometimes you may involve end-to-end, sometimes you may involve in a specific stage, or sometimes you get a help from others, or maybe you are helping to someone. So, but you should have idea about all the steps. Suppose when I'm working on a project, I'm building a classification model, probably you may not get opportunity to work on end-to-end, but you should know. Does that make sense? But sometimes if it's a companies like a small and medium companies, there you're required to take care of the ownership of end-to-end delivery. But some situations like a bigger companies, for everything they have a separate teams, right? There is a team for data acquisition, there is a team for data preparation, there is a team for model building, there is a team for documentation, right? So it depends on the situation. You may involve, you may not involve, but having a knowledge of end-to-end modeling steps really required, since you are going to be a data scientist. Make sense? So that's the reason I'm covering. Don't think that every time you're required to know about all of these things. It's not necessary. Okay. So when I say pre-modeling, this is the place. The first thing is identifying the business problem. Or identifying the business problem, or what is the other thing? So, or maybe validate your hypothesis or business hypothesis. So sometimes you need to come up with a business problem. Sometimes the business will give you the business problem. You need to validate. Right? For example, a business is giving that you are running, they are running a losses. If that is the case, you need to identify why the losses are coming. That is the business problem. But they are seeing that the trend of churn. Okay, the churn of customers. So they already given the problem, which is nothing but churn, and customers are leaving. If the customers are leaving, is that really true? That is something you need to validate yourself. So in both the cases, guys, is everyone able to hear me? Okay, guys, is it better now? Is there any still disturbance? Guys, today my throat is a little not good, so probably you may not see that much clarity. Okay, cool. So what I was referring is, whenever you are referring to the business problem, sometimes you may get the business problem, sometimes you may need to identify the business problem. So this is the place a lot of times you do the exploratory analysis or diagnostics, right? Exploratory analysis or diagnostics, which you require to work on it. Does that make sense? Once that is done, convert the business problem into stats problem. So that means that, okay, so there is a business problem is there. Is it a regression problem? Is it a classification problem? Is it a segmentation problem? Is it a forecasting problem? If all these problems which you know, or sometimes it might be a combination of the techniques, right? So that means that identify the business problem. Identify the type of business problem. So this will also help you to identify what is your Y, what is your X. Yes or no? If it is a regression problem, first what you should have it? You should have your Y variable, you should have your X variables. Then only you can perform a regression model, right? If you don't have a Y variable, can you build a regression model? No, right? So that's the reason, when you are working on identifying the business problem, there itself, what is your target variable? What are the variables which can influence your target variable? So this is the place, sometimes the business understanding, the experience, sometimes the understanding of the context, all these things will help you to understand. Suppose, for example, yesterday, I was explaining the concept of regression. Before that, we solved a simple business problem, which is nothing but identifying the best location in terms of the sales. What did we do there? First, what is your existing data? In the existing data, what is your Y variable? What is your X variables? How did you know what are the X variables? Like, for example, we discussed like parking size, number of, population density, or a number of stores within the location. All of these things, how did you do? Based on the common sense, based on the understanding. So here is the place, business sense definitely help you, but more than business sense, the common sense will help you more. So as I said that, most of the industries you are familiar with, like for example, telecom industry, aren't you familiar with that? How it works? Or banking, aren't you familiar with how banking works? Or, maybe retail, aren't you familiar with retail? So at least try to understand as a user, as a supplier, as a vendor, as a shop owner, think about all the roles. What are their pain points? What are the things which you feel that the data can be captured, which you feel that the data can be helpful? So this is the place over the period of time you will learn. But yes, you need to apply a lot of common sense, a lot of data understanding, a lot of business understanding. That is something which you will learn over the period of time. Once you understand this one, what is the next thing? Data acquisition. So sometimes the data may not be in a one single data source. Sometimes the data might be sitting in a multiple sources. Get the data, all possible data what you need. Correct? So that is nothing but acquiring the data means collecting the data from multiple sources, right? Suppose you are working on a retail project. What are the information you might come across? One is a customer data, one is a transaction data, one is a product information, one is inventory information, one is the supplier information. These are the typical information you may come across. If it is a telecom data, what is the information you may come across? Right. So first customer information, again end of the day, and what is their usage of the product, what is our plans, what is our payment and payment details or recharge details, and what is the customer care information, what is the promotions and campaigns they responded. This is the typical information you come across. Yes or no? So that is, do you need a business understanding for that? It's a more common sense, right? So as I mentioned, there is a very interesting website that might help you to understand the data perspective. Database answers. Database answer, I think. So if you look at this one, so if you go here, there is for every industry, what are the typical tables they are using? What is the typical fields in each table can looks like? So probably this will, for example, a retail bank, or in the retail bank, what is the typical process looks like? Right? What are the typical tables looks like? What are the different dimension models looks like? So this might help you to think over what is the data you should think about it. Right? Probably, you may leverage this website to understand the data aspect or a little bit business aspect. Right? So I will share you along with today Excel sheet so that this will be very helpful. So to understand data, this is the website helpful. And there is another website which is also very helpful to understand this modeling concepts, whatever we are discussing, which is called so there is a person called Syed. So this is to understand modeling concepts, not modeling concepts, data mining concepts. So this might be very helpful reference for you guys, right? And of course, I'm also going to share some more links which will be very helpful in the later point of time. So the beauty of this one is, suppose whatever we discussed till now, like a univariate analysis, bivariate analysis, etc. Like for example, I want to understand bivariate analysis. So if I want to look at the numerical, what is my scatter plot looks like, how the analysis look at, what is a linear equation, what is the correlation, how correlation can be calculated. In case if someone want a little more deep dive also, still this website will be super helpful, right? So as you know, we are in a fast phase of learning, right? So obviously I can't teach each and every small thing. It's not like a spoon feeding kind of thing, right? Some of the things you also need to learn parallelly along with the sessions. If I need to teach each and every small thing, the course cannot be completed in 3.5 months. It will be at 2 years, right? A simple example is the last class. If I look at in the yesterday's class, that is almost, if you take academic course perspective, that is almost 2 papers. 2 papers means 2 semesters you will read. That we finished in almost 3 to 4 hours time, right? So what I'm saying is, you need to little bit understand these conceptual things. I will share regularly what is some of the input information can help you to read through or some reference material. Make use of that and be comfortable with that. Clear? Okay, so now you understand what is data acquisition, and this is the place you need to understand how you got the data. So is the data is everything in at the same level, or some data at a customer level, some data at a transaction level, some data at a product level, information you may come across. So bring all of them at a some level, right? So most of the times when we perform a customer analytics, the data should be at a customer level. Correct? If you are doing a analysis at a store level, store wise, you need to perform the data you need to aggregate the data at a store level. So that is what I'm saying, that aggregate the data as required and create a 360-degree view of file. So sometimes this is what we call as an analysis file. So a lot of times this is analysis file we call it. Even before, when you are doing this acquisition or before performing also, you do some kind of a data auditing, a data understanding. So what is my data about? How the data related, interrelated? How can we combine different tables? What are the data fields you have it? How much data accuracy? Some kind of problems related to NAs, missings. Some of these can be possible. So understand all of these things even before consolidating, before aggregating. So this is the place you need to understand data, and at the same time data audit. Data audit means what you got, is that really correct or not? So that means you need to cross check with your client. You need to cross check with your client what you have a persons in terms of the data understanding or in terms of the quality checks. And once you have done this, then you need to perform some kind of a data preparation, etc. So this is a typical pre-modeling steps looks like. So whenever I was referring that pre-modeling, so this is a typical pre-modeling steps case. Does it make sense? So most of the times, if it is a bigger company or something, a lot of times a data scientist as a junior level may not involve. A senior level person or a manager level person or a business analyst, they may involve mostly in the pre-modeling stage, right? A junior level person may not involve in the beginning. Is it clear? Or maybe sometimes they involve at this stage, like a data acquisition stage, right? Okay, now next step is modeling step. Guys, one important thing, I am giving my view of stages of analytics. Don't think that, okay, this stages is everywhere is same or not. Sometimes, people will consider the data acquisition as part of modeling. Right, so don't get confused around that. If in case if you come across something, don't think like that. So think about high level steps. Okay, now then if you understand this one, so the data preparation is the key thing. For that, again, whatever the file you got it, again what you need to do is you need to create a data audit report at a analysis file. For analysis file. So in this case, there are few things which you will understand. Okay, does my data have any problems? Okay, does my data has any problems? So that means that what I'm saying is like, do we have any missings? Do we have any outliers? Do we have any variables without any variance? Are all the data types, the data types are correct or not? Right? And sometimes these kind of problems, and sometimes you may have some constant values, right? So like this, you need to think about what are the problems in my data. Suppose a variable is there, it's a missing, Why it is missing? First of all, you need to understand from the business. If it is missing, how to handle that missing. That is the next step which we need to do that. Right? First of all, are these problems are existed in my data? Right? So then the data preparation aspect, what you need to do is, first data preparation step one, handling all the above problems, like converting data types if the data types are not mapping. For example, some numerical variable is there, but ideally it's not a numerical variable, it's a categorical variable. Or maybe some date variable is there, but your data is read as a text format. Now you want to convert text to date, right? All of these kind of conversions which you need to understand based on the data dictionary. And handling missings, handling outliers, or understand the distribution, and based on the distribution, the variables, when drop the variables, if a data doesn't have any variance, right? If it is a replace some constants with specific values, or sometimes you need to create a derived variables. What do you mean derived variables? Like for example, some variables are there, if you use as it is, it won't make sense, right? So a simple example is a date of birth. The customer date of birth is there. Will you able to use that variable as it is? You have to think about age as a variable. Or you have a first transaction date. Will you able to use that? Maybe you need to calculate a tenure. Or maybe you have a last transaction date. What will you able to do that? Number of days inactive. So like this, you can think about some variables which are making more sense with respect to context. Or maybe some financial data you have it, like income is there, spend is there, how much saving you can do that, you can calculate. Or income is there and spend is there, how much profit you have it, you can calculate. So some of these kind of things which I'm saying that creating a new variables with the help of derived variables. And again, this is not something you will do with the statistics, right? This is something you will do with the business, something you will do with the data understanding, something you will do with the common sense, right? So exactly, Lucky. So sometimes that kind of a variables you need to think about it. Yeah, you are saying? Variables without any variance means, for example, income is there, income of a customer. So in your data, all the customer having the same income. All of the customers having a 5 lakhs, 5 lakhs, 5 lakhs. Is that variable helpful for you? How will you differentiate that customers? Right, so that's what constant, without having any variance means. Don't have any variance, I mean to say less variance. So, less variance. Yes, of course, if the variable is constant across all the values, across customers, the value is constant, how it will be helpful for you? Does that make sense? Yeah?
Suppose we are new to a certain domain, and if we give a use case and we have a table with lot of columns, some 200 to 500. Now the data, I know what is my target. Now how do you actually find out which are the data or the columns that I'm supposed to choose? Important ones.
That we will talk about little later. So at this point of time, what I'm saying is, if you have a data, if you identify some set of problems, how to handle that. Okay. So sometimes this handling missings, handling outliers, we'll discuss about that, how to handle that, etc. So the next important thing, okay, replace constant with a specific values. What do you mean that is? For example, sometimes in the database, what happens is, suppose some value is missing. What they do is they will replace with a 999 or maybe some constant value. So you need to understand what is that constant means, right? So that is again, it will comes from the data dictionary or a data understanding. Make sense? Okay, so this is something which I was referring that, okay, handling all the above problems. That is my data preparation step 1. My data preparation step 2 is more like assumptions, right? Whether the data is following set of assumptions. So the assumptions is for a specific to technique. Suppose if I'm using a linear regression, the linear regression will have certain assumptions. If I'm using some other technique, they may have some assumptions. So you need to make sure that are we following the assumptions related to the technique, right? So again, these assumptions also will help you sometimes as a variable reduction. So as you mentioned that, so if, for example, in this case, even the data preparation one also help you to reduce the variables partially. How this will help you to reduce the partially? Like for example, a variable with high missings. Variable with high missings. What does that mean? If it is greater than 25% of missings, then I generally don't consider part of my model. I will drop that variable. Or variables with less variance. So that means that a coefficient of variation CV is less than 0.1. I may not consider it in the beginning, right? And once I derive some variables, I will drop the other variables. Like I drop unnecessary variables. When I say unnecessary variables, I mean to say that, like for example, a customer ID. Do you think customer ID is right? Or once you derived some variables, the source variables. I mean, drop source variables once you calculated the derived variables. So like this, you can also drop some of the things which won't make sense. And sometimes variables, if you suppose categorical variables with more number of levels. Suppose a location is there, you have 100 locations. So probably you may drop that variables in the beginning. Okay, so like this, in the data preparation step 1 itself, some of the variables you may drop it. Is that clear? Now the second step, data preparation step 2. Data preparation step 2. Here is the place what we do is, most of the times we will check the assumptions of your technique. Suppose if I'm using a linear regression, so assumptions of linear regressions. So one is your y should be normal, and the second thing is your y and x should follow a linear relationship. No outliers, no multicollinearity, or no heteroscedasticity, no autocorrelation.
Multicollinearity means no identical values.
I will discuss that. I will discuss all of these things. So we will come back these pointers in a while, but I'm saying that basically in the data preparation step 2, are we following the assumptions of the technique? If you are not able to follow, that means if the data is not following those assumptions, what you need to do? So in this case, what you need to do, if the assumptions are, if the data follows assumptions, no problem. Okay, if the data not follows assumptions, you need to make sure that the assumptions follows by doing some data preparation. So most of the times in the data preparation here is transformations of variables. A simple example, if y is not following a normal distribution, what will you do? You will apply some kind of a transformation on y such that the new variable follows a normal distribution. A simple example, income is there. Income is not following a normal distribution. That is your target variable. You want to predict the income of customer, for example. Now, if the income is not following normal distribution, ideally you should not use linear regression. For that, what will you do? You will apply some kind of a transformation in such that the new variable follows a normal distribution. For example, I am applied a log transformation. I applied a log transformation on income. So now you got a log income. Now check log income is following a normal or not. If it is following, that is your transformation. Does that make sense? So that is what exactly I was referring, that if y is not following a normal distribution, making sure that y is following a normal distribution by applying some kind of a transformation. Similarly, y and x should have a linear relationship. What do you mean that? What do you mean linear relationship? If y is a numerical variable, x is a numerical variable, how can you ensure that it follows a linear?
X increases by.
Yes, that is nothing but what the correlations. That means some kind of a correlation, you should have it. If x is not having a correlation, what will you do? Apply some transformation on x such that your y and the new variable follows a linear relationship. That's nothing but the correlation is high. Does that make sense?
Could you just explain that one, the last part?
So I am referring that your y and x should have a linear relationship. That means that what? The correlation between your y and x should have some significance, some correlation should be high. Suppose a correlation between y and x is close to 0. That means that you can say that there is no linear relationship. Now what I'm saying is, take some kind of a transformation like for example log x or a square root of x or a square of x or exponential of x. Take this one and look at the correlation between your y and the log x. A correlation between your y and the square root of x. Right? So suppose you are getting this one. So what I'm saying is, if you are getting this one, this is you got the point 0, 1, and this is a point 2, this is a point 3, 5, this is a point 1, this is a point 1, 2. Suppose. Now which one is a best transformation in this case? Square root of this one. So that means that instead of using a normal x, I will use square root of x. So that's how you will making sure that they have some kind of a linear relationship. And no outliers. I will tell you why you don't need outliers. So I will tell you later point of time. And outliers, you understand, right? Outliers means not just only for y variables, it's also applicable for x variables also. Okay, anyway, this outliers for generally we deal in the beginning itself, so there is no problem. But yes, in case if you don't handle here, maybe you need to making sure that the outliers taken care of here also. No multicollinearity. Multicollinearity is something what I am referring is, if all the x variables are there, if the x variables are there, if the x variables within the x variables if there is a relationship. So that means that you have x1, x2, x3 and x4. Suppose 4 variables you have. If there is a relationship within the 4 variables, that means if one variable you are able to express as a combination of other variables. If one variable expresses, or maybe you may not have a very strong relationship between these two, or maybe x1 and x3, or x1 and x4, you may not have a very strong relationship. But between x1 and other combinations, x2, x3, x4, if there is a relationship, that means one independent variable expressed as other independent variables, then we call it as a multicollinearity. So I will tell you what is the reason, the assumption, but at least at this point of time, what you need to understand whether multicollinearity exists or not. If the multicollinearity exists, what you need to do? Suppose if x1 is able to express as these 3 variables, what will you do? You will drop x1. Yes or no? Because that is what exactly the same thing talking about. So that's also will help you to reduce your variables. So Pratyush, that's what I'm giving the example, right? I'm saying that if you have a 4 variables, if I'm saying that my x1 is a 3 times of x2 plus 2 times of x3 plus minus 4 times of x4. This is nothing but what? You're able to express one variable with the other variables. It's not necessarily exactly the same, just like a regression. One, it's a closely mapping with the other. So that means that instead of using x1, you can also use x2, x3, x4. It's a linear relationship again, because since we are referring to the linear regression.
Hello.
Guys, can you hear me? Okay, cool. So are you able to follow me now? What is a multicollinearity? Multicollinearity is something nothing but if you are able to express one independent variable with other independent variables, then we call it as a multicollinearity. Okay, so we'll also discuss about these two things also a little later point of time. At this point of time, at least understand what are the assumptions of linear regression. So why we need to follow these assumptions, that is it. We'll see that. What is the consequence if you don't follow that? Okay. So that is what the data preparation step 2. Okay, now if I'm using some different technique, you need to take care of the assumptions of that particular technique. Now, at data preparation step 3. So this is nothing but more like a feature engineering. So of course, when I say feature engineering, primarily one is variable reduction, variable generation, or variable reduction, right? So these things also. So I mean to say that these steps we also followed in the previous steps also. Some of these steps will also help you to reduce the variables. Some of the steps also help you to create a new variables. But still, in the step 3, which will more on the business aspect, do we need to create some more variables? Do we need to apply some more transformations? Right? So those are the some things which you do that. And the most important thing is variable reduction. So what are my most important variables with respect to my model? So that is what exactly we call it as a data preparation step 3, which is nothing but feature engineering. So how to identify most important variables. So this is the place we have some of the statistical methods like a correlation, regression, so correlation, chi-square, or ANOVA, etc. will help you. So because, for example, if I have y variable, if I have x variable, how to identify whether there is a relationship between your y and x depends on what type of y and x. If both are numerical, you may refer a correlation. If one is categorical, one is numerical, you may refer ANOVA. So this bivariate relationship sometimes will also help you to reduce the variable. And the other set of things like, we have a principal component analysis or a fact analysis. These both are referring same manner, either fact analysis or a principal component analysis. This is one method. There is another method called F regression. So that means that it is similar to ANOVA, but we will talk about a separate technique. And there is another technique called RFE. It's a recursive feature elimination. Or sometimes we use decision trees to identify important variables. Right? Sometimes we use a concept called VIF, variance inflation factor. So like this, some of these steps, some of these methods can help you to reduce the variables statistically. Does it make sense? If the variables are, you have a huge number of variables, how to reduce? These are some of the methods can help you. Of course, in addition to that, if you have some kind of business understanding, some of things that might help you further. But what I'm referring is statistically, if I don't know any business knowledge, if I don't know anything about the context, still I can perform some analysis without knowing some business understanding, and that's the place these methods can help you. But as I said that the business sense will always help you. I'm not denying the fact. I'm saying that even if you don't know some business sense, still some of the statistical methods can help you. Is it clear now? Once we have this data preparation step 3, then what will you do is, you will split the data into train and test. So what do you mean that train and test? So this is the place, you remember yesterday I was saying that you build the model, but how confident you are the model is going to work on new data. If the model is not working on new data, what is the use of that model? Right? So before implementing, I will make sure that my model is working on new data. So this is what exactly we also call it as a cross-validation specific. So here what I will do is, okay, generally if I have a full data, so probably I may split the data into either 50-50, or maybe I will refer 70-30, I may refer 80-20, something like that. So what I mean to say that is 50% of observations you will build the model, 50% observation you will check whether the model is working or not. Maybe sometimes 70-30. 70-30 means when you have little less amount of data, then what it means is you will use more data for model building, because you need more data for estimating or identifying the patterns and estimating the betas. So that's the place you will give a little more data to creating a model. But at the same time, you also want to validate that model, so you will keep some 30% or 20% of the proportion of data to make sure that your model is working on new data. So what I'm trying to say is, you are splitting, for example, 1000 observations are there, probably you will split the 700 observations and 300 observations. 700 observations will be used for model building, and 300 observations used for model testing. So that is what the train and test means. Why do we need? To get a confidence, to make sure that your model is working or not. If your model is not working, there is no use of that model when you are implementing. How will you get confidence whether the model is going to work or not? Right? So once this is done, the next important thing is model building. Building a model. So when I say building a model, what does that mean? Estimating the mathematical equation, mathematical relationship. Right? So this is the place you need to make sure that your model is working or not, your all the mathematical relationship is making sense or not, which variables to use finally, which variables to exclude, etc. Right? So that means that you will identify final list of variables and identify a final mathematical equation. Right? So once you are this one, and at the same time you also need to make sure that assess how good is your model. So this is the place, the model metrics. You remember the model metrics, like yesterday I was referring the R-square or referring the MAPE or RMSE, and all these metrics we will check it whether my model is giving a decent accuracy or not, or as expected accuracy or not. Right? So that is something which you need. In case your model is not as per your expectations, what you need to do? Again, you need to revisit, are the assumptions we followed correctly? Is the data is, sufficient, or do we need more data? All of these things which you need to revisit this is the iterative process. It's not like in one go you will get a model. If that is the case, the automation can be done. Then what is your role? Right? It's a more like iterative process. The human decision is more important. So that is the place you will play a little bigger role to understand what is your model metrics, and you will make sure that why the model metrics are not up to the mark. What could be the reason? Okay, once you're satisfied with your model metrics, then what will you do? You will validate your model. So that means that you will use mathematical equation relationship and predict the value for test data. This is what we call it as a scoring. Right? So you got a mathematical equation. Using that mathematical equation, predict the values. For the test data also, you have actual, you have a predicted. Once you have actual and predicted, you can calculate all these model metrics for validation data also. So now compare the metrics. This is what we call it as a goodness of fit metrics, right? Goodness of fit metrics for both training and testing data. Okay, I got RMS MAPE, 25% in training data, but in validation data I got 40%. Does that make sense? Or in training data I got MAPE, RMSE is 5, and testing data I got 1. Does that make sense? So this is the comparison you need to do that will help you to making sure that your model is working on new data. Right? So once you model validation done, this is the model stage, or model building stage. This is the second stage of overall model building. So this is what we call as a modeling. Now once this is done, then what is that? Post modeling. Once you've done this one, the post modeling. In the post modeling, there are 2-3 things you need to make sure that you statistically your model is making sense, but a business perspective is that model is making sense. So this is the place we will do a business validation. Okay, so you identified churn is one of the big problem. For that you build the model. You identified, okay, the managers are not good. That is the key reason you got it. Is that business validation perspective is correct? May or may not, we don't know. So that's the place the business had to take some kind of a decision. Is my model is really implementable? So when I say business validation, that doesn't mean that is it correct or not. It means that can we implement this model, or can we implement these recommendations what you got it from the model in the business perspective. So that's also sometimes you need to understand. Does it make sense? That is what the business validation. And then the documentation. The documentation perspective, okay, the complete steps, including assumptions and data preparation, everything, and pros and cons. I mean, what situations your model may work, what situation your model may not work, right? And implementation code. So that means if I want to implement on new data, what is the data preparations I need to do? Because if you remember, if I perform a missing value treatment in a training data, I need to perform missing value treatment on the new data also. Whenever I'm scoring the rate, it should be apple to apple comparison, right? So that is the implementation code I need to write it. And once this is done, some of the outputs. Okay, what is your business problem? What is your recommendation? So most of the times either a deck of slides. So it's nothing but starting with the problem and complete the end-to-end outputs. How good is your model? Comparison of model development and validation, training and testing, and what is your pros and cons? What is the data assumptions you have taken? Whatever the documentation is a detailed documentation. The outputs is more high-level comparisons. Does that make sense? And then you also need to come up with a tracking the model. What do you mean the tracking the model? I mean to say that, is this model going to work forever? It's not necessary. Today it's working. Maybe after 6 months, the model may not work because the data may have changed, or there could be a number of reasons. So is that my model is going to work in the after 6 months or after 8 months or after 9 months? How to cross check your model is working or not? Or if my model is not working, what I need to do? Right? So that is the tracking. This is also nothing but a model validation also. It's a continuous model validation. So there is a separate team will be there. They always check whether models are working or not. Right? So these are the typical steps. And of course, one interesting thing when you are doing the outputs, there is one more thing. You need to calculate the ROI. Okay. If I implement this model, how a business will get benefit? A return on investment. So if I implement this model, how business will get benefit out of it? So end of the day, if you are unable to showcase whether model is going to give any benefit, why business will implement? Right? So end of the day, what they want, they need to solve the problem, but what kind of implications on the revenue or a profit or some kind of a metrics, that's what we call as a KPIs. So you need to calculate some KPIs with respect to ROI. Right? So guys, as I said that these are the exhaustive steps. So in a practically, sometimes people don't follow each and everything. For example, if the data doesn't have missing values, will you do the missing value treatment? If the data, you already got a one single file, will you perform the data consolidation, all of these things? If the data doesn't have multi-column yet, will you perform that? Right? So what I'm saying is these are exhaustive steps. It depends on the requirement, it depends on the context, it depends on the situations. You may use all the steps or may use the partial steps. Right? If you have very few variables, will you perform the feature engineering step? Like for example, 20 variables are there. Do you require to perform a PCA or some other analysis? I don't think so. But there, it's more understanding, a quick iterations can perform easily. So what I'm trying to say is, these are the exhaustive steps. Sometimes you may use, sometimes you may not use, but having a knowledge is more important. So that's the reason I kept all the things in a one single sheet, so that you will able to understand what it means. And as I said that the steps will be remain same for every technique. What is may change? The may change is the Y may change, X may change, or the data preparation steps 2, which is nothing but the assumptions may change, but otherwise a matrix may change. If it is a regression problem, you may have some set of metrics. If it is a classification problem, you may use some other metrics to evaluate your model, right? But the concepts of high-level steps will be remain same. So whatever technique you are going to use in the later point of time, so the steps may be more or less similar. Of course, there are slight changes you may need, because some techniques doesn't require a data preparation at all. Some steps require some of the data preparation steps. Make sense? Any questions? Guys, if you follow these steps well, I think your 70% of learning related to technique is done. Only change is the algorithm will change. So that's the reason I'm investing a lot of times as a foundation, because once you are comfortable with these steps, what I need to do, I will not follow all these things again and again. I will not explain also. It doesn't mean, right? So suppose if I explain missing value treatment, the same step will also follow in classification. Do I need to explain that? You should be able to understand. Is that clear? So that's the reason I'm investing good amount of time to set the foundation. Any questions? Okay, if you don't have any questions, what I will do is I will take one business problem, right? So the business problem is very simple. So you may aware of automobile sector. So automobile industry, of course, one of the key thing is product development. So product development means, so like for example, you want to come up with a new car. So how analytics play a role? So end of the day, if you come up with a product, what is the ultimate objective? It should sell more. Yes or no? If you are unable to sell more cars, whatever car it is, what is helpful for company, right? So that is the ultimate goal is to increase the sales. Now the company want to understand, if I want to launch a new product, what are the key things I should keep it in mind? What are the key drivers of a sales of a car? Does that make sense what I'm trying to say? So the objective is, what are the key drivers of a car sales? Key drivers of car sales, so that my product, my new product, that means a new car, can have these features to increase to get the high sales. When I say sales, don't think that in money. Sales in terms of number of cars, volume, right? So here I'm saying that the sales is nothing but a number of cars. That is nothing but high volume. Does that make sense? So here is the place, two things you need to understand. Suppose I have 10 drivers. Suppose 10 variables or 10 features are influencing your car. Okay, but out of this 10, if I need to shortlist top 5, how will you identify? So that means, what are the factors I need to give more importance? And sometimes the sales can be influenced by positively, some drivers positively as well as negatively. So what are my positive drivers? I should keep it in mind. What are my negative drivers which I should avoid? A simple example is, if price is high, will you get more sales? You may not, right? Right? If for example, a simple example is an engine having a horsepower, the power of engine is very good. Will you use in cities? What is the use of having a high power of engine in cities? But whereas if you are going for a vacation, if you are going for a long route, long drive, etc., there you may need a horsepower is very high, and that's what we sport models, etc., will comes into the picture. So the reason I'm saying that sometimes the drivers might be positive, sometimes the drivers might be negative. Suppose the price is a very important driver. What you need to keep it in mind, your new car should have a decent price, not like very high price. If you are thinking about, the car is the sales is very you want to increase, but price is not in your control, what will you do? You will look at other alternatives. Yes or no? So that is what the objective of the business problem. Suppose in this case, if you assuming that the car sales, for example, the sales of car, what are the different parameters can contribute to your car, sales of car? Suppose you are a user of car, what is your expectations if you want to buy? Probably sometimes people will give a mileage or engine capacity or space, or maybe a safety, like other, these are all are some product attributes like AC or spacious, or you have the music. All these are all are accessories basically. The AC and these are all accessories. It's not a product. That's the reason generally what they do is they will come up with the 3-4 versions, variants. You know that every more or less every model, every car will come up with a 3-4 variants. High, medium, low range, etc. Why they will keep? The engine is same, the car is same. Why they changing? Some additional accessories. Am I correct or not? Okay, so I mean to say that one is sometimes you look at the product attributes, sometimes you look at pre-attributes. Things like the sales. So the salesperson is able to explain everything about the product. Right, so he's giving the right communication, he's giving some information, he's even marketing, spend marketing budget also. Sometimes you got a car, but no, they did not give any advertisement. How a customer will know? That is also sometimes helpful. And the post, thing, so like service, the customer care, right? These are also sometimes help you in a long run. Right, so that means that there are multiple things like some of the price can be influence your sales. A type of car can influence your sales. As I said, the type of car means a sport car or a regular car or a vehicle, passenger vehicle, or what type of, like passenger vehicles like Innova or Tata Sumo. These are kind of a passenger vehicles. They are not meant for individual users. Very rare. Correct? They are more like a transportation companies generally use. Correct or not? But whereas a sporty car, generally people don't prefer to use in cities. Or whereas a regular cars, normal vehicles, what generally we do, we will use it in regular things. Right? So it depends on, right, which car is more helpful. So these are all are different product attributes or marketing attributes, some other attributes which can help you to increase the sales. Do you think or not? So what I'm planning to do is I will take some kind of a data which is each car model level. Okay, so different manufacturers are there and different car models are there. Each car model, I also have sales. When I say sales, I mean it is the number of cars sold. Don't think that it's amount, because one Benz car is same as a 100 maybe Alto cars. Am I correct or not? Maybe a Range Rover is almost to 50 to 60 lakhs, and same thing you will get a 20-30 cars. I'm not talking about that. I'm talking about number of cars sold. So that's how the success ratio will define. Make sense? Any questions? So I think Sandeep is also mentioned that like the diesel engines are not allowed in some countries, even in it is depends on not only countries, even state wise also that the changes will, like for example in Delhi NCR now the diesel they're about to ban, right? So like that, because of the pollution, because of some reasons, right? So what I'm going to do is I'm going to take that data set, and first of all I will try to understand what is driving my sales, and if I want to launch a new product, if I know these three drivers, what is the approximate estimated sale you can expect, right? So that means that what are the key drivers? That is the first thing. The second thing is identify or predict car sales for given drivers. Does that make sense? And not only that, when I say key drivers, identify a positive or negative drivers and rank them. What do you mean rank them? Which one is most important? Which one is less important? The relative importance. The importance of drivers. So is this make sense? Is the business problem is clear? Any questions? So I will show you the data set. So the data set is something like this, guys. So manufacturer, model, sales in thousands. What do you mean that sales in thousands? Number of cars sold, that is 16.919. That is nothing but 16,919 cars sold. And in a lot of times, for example, your car sales is depends on the resale value also. For example, a lot of times people prefer Maruti car, it's because of resale value. Or maybe Hyundai car, they're because of the resale value. But whereas a Chevrolet or some other things, they may not prefer because the resale value may not be that great. And vehicle type, I told you, is it a passenger, is it a vehicle, car, or what type of car it is. Price, price of vehicle, or size of engine, or horsepower, the wheelbase, width, length, carb weight, fuel capacity, fuel efficiency, latest launch, or power performance factor. So that means that when it was launched, or power performance factor, how quickly you can reach a certain mileage, something like that. So do you think these are all our product attributes or not? Of course, I did not include the marketing related or post sale related, etc. The reason is I want to make it more product feature perspective. Now, what is your target variable in this? Sales in thousands, and the rest all can I consider as X variables? So now you understand, is it a regression problem or not? First of all, that is important thing. It's a regression problem. You know your Y, you know your X. Now what we need to do? We need to import the data. So for a simplicity perspective, I got the data in a consolidated manner. Sometimes what happened is the sales information, resale value, you will get it from the external sources. Sorry, price will be your end user, distributor level you get the info, but the resale value you will not get this, right? You will get it from the market, some external source. These are all the things are product specifications. Sometimes you will get it from the research team or a product development team or individual companies. So like this, sometimes you may have the data in a one single file, or sometimes you may have data in a different files. You need to make sure that consolidate everything in a single file. So since I'm doing it at a product level, my file is at a product at a model level. We'll discuss about that. But at this point of time, I'm saying that the pre-modeling stage, whatever I was referring that, what is the pre-modeling stage? You remember the pre-modeling stage, all of these things which I was referring that, like what is your Y and what is your X, collecting the data from multiple sources, data understanding, data editing, we will do that, but having a single file. Is that correct or not? So this is what exactly I was referring that the pre-modeling stage. Of course, in this case, I given the problem. I given the data in a single file, but generally it never happened like that. Sometimes you may have the problem, sometimes you may not have the problem. Right? So that is what I was referring that. Okay, if you understand this one, what are the typical packages which we have yesterday? You remember I discussed what are the list of packages are available in so you remember the data importing, data processing, data understanding, data visualization, all of these things we already discussed about. NumPy, Pandas, Matplotlib, Seaborn, SciPy, these will be helpful. But whereas in modeling perspective, scikit-learn, stat models will be very helpful. Right? I think these are the packages which you need to make sure that imported these packages first. Is that correct or not? Sometimes you may use all or sometimes may not use all, but these are the common packages which we really look at. Okay, so in this case, the most important thing is the scikit-learn. And scikit-learn has a wide variety of features. It's a very big library, a very big module. So this is used sometimes a data processing or a data understanding or a feature engineering or metric calculations or splitting the data or model building or model validation. So most of your steps may be solved or may leverage your scikit-learn to come up with all these steps. Does it make sense? So I'm saying that this is the one library which you a little bit more spending more time, just like a Pandas. It's a very huge library, right? Pandas also. And similarly, scikit-learn is another big library which will be used, right? So I will also introduce what is scikit-learn and what are the key features of scikit-learn, etc. So I will talk about that. So if you want to see the scikit-learn, so I'm going to share this one. So as I said that scikit-learn is something which is used for a machine learning library written in Python, and it's very easy, simple, and efficient. And there are almost all machine learning algorithms related to regression, classification, segmentation you may find out in scikit-learn. And of course, as I said that scikit-learn have a different modules, like a scikit-learn base, which is nothing but a base class of all estimates, like all algorithms. And scikit-learn calibration, I will tell you what do you mean calibration. I told you cluster is nothing but doing the cluster analysis, or cross validation, cross decomposition, and sometimes scikit-learn have data sets. So almost all algorithms required to perform some kind of examples on your own. So it also comes with certain sample data. So that is the data sets. Like decomposition is something which we'll use it for singular value decomposition or etc. This will be, performing PCA, etc. We will use this decomposition more like performing PCA, ICA, NMF. These are all different algorithms. Like discriminant analysis, ensemble learning, feature extraction, feature selection, some of these things, and imputing missing values, building a linear models, getting the metrics, performing some model selection, and doing some kind of naive-based models, neighbors, neural network, performing some kind of a pipelining. That is nothing but creating a pipelines. Everything can be done automated in a single piece of code. Scikit-learn pre-processing, all of these things. Out of all of these things, there are few things which we use very commonly. One is the tree models, decision tree. So you can find out all the algorithms related to decision trees. This is a support vector machines. And this is a scikit-learn pre-processing, especially when I say pre-processing means like doing some kind of normalization, some kind of standardization, and converting categorical variables into numerical variables to categorical variables, encoding, all of these things which we'll talk about. And again, this is another important thing like pipelining. Pipelining, as I said, that you have a multiple steps. You want to write a single piece of code, a single line of code, and that kind of situation, the automation purpose we use a pipelining. And the neural networks we use for implementation of neural networks in Python. Generally, neural networks these days, people are not using the scikit-learn. Most of the times they are use a TensorFlow or a Keras. So sometimes you may use scikit-learn, sometimes you may use Keras and TensorFlow. Those are also a similar kind of a modules, packages. And k-nearest neighbors, KNN kind of a situations, we use this one. In naive-based purpose, we will use this one. And the multinomial classification perspective, you may use multi-class model. And metrics, I told you, if the model is, suppose, as I said that if it is a regression model, I want to calculate certain metrics like a mean squared error, mean absolute percentage error, or a similarly classification problem, you have certain metrics. So instead of doing on your own, there are certain predefined methods which can help you to calculate the metrics, right? So, and linear model, I already told you, linear regression, logistic regression, lasso regression, Bayesian regression, gradient, all the ridge regression, elastic net, all of these generalized linear models will be available under the linear models module. So that is one thing which we use it. And of course, imputation, probably you may not use it, but in case if you want to create some kind of pipelining, etc., probably we use